All right, let's examine an object going down an inclined plane at a constant velocity. And I want to figure out what is the coefficient of friction between the object and the surface. So the object's going down a inclined plane at a constant velocity. So let's draw the FBD. So I have an object. I would draw the normal force, always. It's going down the inclined plane, which means friction is going to go this way. We have the weight, which goes straight down, but if you watched the last video, we can resolve that into two forces. One going down the inclined plane of weight sine of theta, and one going into the inclined plane of weight cosine of theta. Okay, so what do we know if this is going down at a constant velocity? That means there is zero net force, and it means that this force and this force are equal to each other. So I can start by with that premise. So I could write mg sine of theta. Mg is weight, remember. Mg sine of theta equals friction force. Then I could write mg sine of theta equals, what is friction force? Friction force is mu times normal force. So then I could write mg sine of theta equals mu times, what is the normal force? Well, in this case, there is no acceleration in the vertical direction, so the normal force would be equal to w cosine of theta, or mg cosine of theta. If you look at that, mg's would cancel out on either side, and you don't need to know the mass of this object. And if I solve for mu, I get sine of theta over cosine of theta. And you might know that trig identity. Mu equals tangent of theta. So all I would have to do to find the coefficient of friction is to take the tangent of that particular angle. Now, this is sometimes bad for students because students start to think that anytime you ever want to find the coefficient of friction, you just simply take the tangent of the angle. And of course, that is ridiculous and cannot be true, because I could take this object off this inclined plane right now and line the bottom of the object with sandpaper and line the surface of the inclined plane with sandpaper, and therefore I would have drastically increased the mu. But the angle's still the same, so if I take the tangent of the angle, wouldn't I get the same mu? And of course I'd get the same mu, but that would not be the mu. But also, that object would no longer be going down the inclined plane at a constant velocity, and that is the key. You can only use mu as tangent of the angle in the situation where you have an object on the inclined plane and it's going down under its own weight component, going down the inclined plane at a constant velocity. Then and only then could you use this quick little equation. You simply take the tangent of the angle, and you would know the coefficient of friction only in that situation. Very important to remember that.